Hi everyone, welcome to lesson 4, Binomial Theorem. Today we're going to start to talk about Pascal's triangle. It's this triangle over here, it's a mathematical triangle where on your outer edges you always start off with that number 1. In this first row here, you're just 1, on the next row you're just 1 and 1, so you're just building the outer edges. But now on this third row, it's a combination of your previous row. So here on the outer edge is 1, right in the middle is a combination of 1 and 1, so 1 plus 1 there gets you to 2, and on the outer edge there's a 1 again. On the fourth row, it's still 1 on the outer edges, but this time you have 3 here because you went 1 plus 2 equals 3, and 2 plus 1 equals 3. And continuing on, that's the bottom of your Pascal's triangle. This, of course, goes on indefinitely, and you need to stop wherever you need to stop, but this ties into our combinations over here as well. Our values of our combinations, that is. So if you had 0, choose 0, that's still one option because you're choosing no options. If you had 1, choose 0, and 1, choose 1, both are one options each, and so on and so on. So again, all these numbers match up exactly to Pascal's triangle. Right here we have a table that says the sum of the rows of Pascal's triangle. So we're going to finish off 2 more rows of Pascal's triangle. We're going to sum it up, we're going to add it up in this column here, and we're going to simplify it in this last column here. So here we go. So again, I'm going to start off with my edge numbers. So it's going to be 1 and 1 right on the edge there. 1 and 4 should make 5, 10, 10, and 5 again. Again, edge of 1 and 1. And this one would be 6, 15, 20, 15, and another 6. So we could also do this for n, but we'll just write down in our equation instead of drawing out a Pascal's triangle. For these sums, we have 1, 2, 1, 2, and 1 make 4. 1, 3, 3s, and 1 make 8. So you got 1, 2, 4, 8, 16, 32, and 64. If these numbers don't seem familiar to you, I can rewrite these exact same numbers in this format here. 1 is the same thing as saying 2 exponent 0. That's 2 exponent 1, 2 exponent 2, and so on and so on. That's cubed, 4, 2 exponent 5, and 2 exponent 6 right there. So what's our general equation here? So the number of rows, n, and our sum, the way that they're going to be related is it's going to be base 2 n, but then notice here, my row was 7, I needed 6, my row was 2, I needed 1, my row was 3, I needed 2, so it's going to be n minus 1 for our general equation there. Here's binomial expansion. It basically uses Pascal's triangle. Binomial expansion is just a fancy way of saying multiply out. The first one here we've done in previous math. Anything exponent 0 is always 1. Here, this is x plus y exponent 1, so that means everything gets everything gets exponent 1 to it, and then you can just simplify here. This one here is your binomial, so this is x plus y times another x plus y, and if you distribute it out, you would have gotten to the exact same answer here. But if I gave you a cubic or a exponent 4, you don't want to spend your time just multiplying each one of these out. What you can do is use Pascal's triangle to write down all your coefficients. So 1, 1, 1s, all on the edges. All your numbers in between are, again, the numbers straight off of Pascal's triangle. All your coefficients are Pascal's triangle. The harder part now is to trying to figure out all the exponents on everything. So, what do you notice about the coefficients in the expansion? Same numbers from Pascal's triangle, and hopefully you notice that. So they are all the same numbers from Pascal's triangle. So let's just write a quick note. Same numbers from Pascal's triangle. Without actually mapping, what would without multiplying, what would x plus y exponent 6 be? Well, let's use Pascal's triangle to solve this. we have 6 up top there, and what I'm looking at is if I'm exponent 6, that's going to be my sum. I want that 2 exponent 6 sum. So how do we do that? That's really row 7, by the way. So we would have 1, oops, switch colors, starting off with a coefficient of 1, it'd be x exponent 6. Then we're going to add on, the next coefficient was 6, x, and in this case all my x's are going to be decreasing until I get to 0, all my y's are going to be increasing starting from 0. So this first term here technically had a y exponent 0, that's just 1, it cleans up, it simplifies, goes away. So here I have x exponent 5, y exponent 1. So in total my degree is still 6 for each one of these terms. Next term, 15, x to the 4, y squared, 20, x cubed, y cubed, and again, degree in total, still 6, coefficient from Pascal's triangle. We're adding on 15, this time x squared, y exponent 4, plus 6, x, y exponent 5, and finally, plus 1, y exponent 6, because this should have been x exponent 0 here, but again, anything exponent 0 just simplifies to 1 and gets multiplied out. So this here would be x plus y exponent 6. So without multiplying, without doing a ton of distribution, you could just simply use Pascal's triangle and write this down. So again, which row, quick note, which row were we looking at? If it's exponent 6, this was row 7, right? And so we were looking at 2, 7 minus 1, which would get you to 2 exponent 6, and this exponent is what was this one here. So it'd be 7 minus 1, n was 7. In general, what's this going to look like? So in general, this is our equation here. And all you have to do is just follow the pattern more or less. So it's going to be n choose 0, n choose 1, all the way up until you get to n choose n. And your exponents start from x exponent, highest exponent there, whatever n is, and then it just slowly decreases, whereas your y's, starting from y 0, will increase until you get up to n. There are blank terms in the expansion. How many terms are there in the expansion? Well, if you had n, and let's go back, let's do a concrete example here. If n was 1, how many terms is this? We have 2. If n was 3, how many terms do we have here? We have 1, 2, 3, 4 terms. If n was 6, how many terms do we have down here? We have 1, 2, 3, 4, 5, 6, 7 terms. So there are blank terms in the expansion. Here, there's always n plus 1 terms. The sum of the exponents of x and y in each term is n. Your degree is n, so all your x's and y's exponents have to add up to n. The exponents of x start at n, starts at your highest, and they're going to decrease. And your exponents for y start at, and I'm going to do this in a different color, start at 0, and they'll always increase. The sum of each row of Pascal's triangle is, and if you added up every row, 2 to the n minus 1, and that was your total sum. The general term for the expansion, right here. So if I ask you for a particular term, you can use this equation to find it. If I ask you for term, let's say term 3, well then it'd be k, whatever your k value is. You want term 3, so it'd be 2 plus 1, because that gets you to 3, and then you just run it in here, where each k is 2. Your n would be whatever you started off with. C is going to be your, this n choose C is going to build your coefficient, and you have your 2 variables right here. We're going to just expand a few of these out. We have a few examples to work through, so here we go. Expand the following, expand using the above pattern, sorry. So, our above pattern uses this here, n choose k. So let's jot down a few things before we attempt this. In this first question here, we have n. Let's do it. Let's do it just down the column here. N, which is 4. K would be whatever term you're looking at. So there's max is 0 through 4. So K would be anything from 0 all the way through 4. What other variables do you need? And then it's just x and y. So x in this case here, x is going to be equal to x here. And y in this case will be equal to positive 3. All right. Let's write down our expansion. So you have n, which is 4. Choose 0. That's going to be my first term there. X to the n, which is 4 minus 0. And y, which is 3. And that's going to be to the value of k, which is 0 for this first one. And really, if I wanted to, I could put brackets right around each one of these here. And then I can clean that up in a second here. But I'm just going to write down all my terms here, and then I'll do a cleanup step. So that's going to be my first term, adding on. 4 choose 1. X 4 minus 1. 3 exponent 1. Plus 4 choose 2. X 4 minus 2. 3 squared. 4 choose 3 is our next one. 4 minus 3. 3 cubed. And finally, 4 choose 4, and this is where we'd stop. X to the 4 minus 4. And our y value, which is 3, that's going to be exponent 4. And there we go. And this is my full expansion right now. This is my setup. From here, I'm going to evaluate each one of these. So you could use your calculator and go 4 choose 0, 4 choose 1, 2, 3, 4. You could look back at your previous Pascal's triangle. Whatever works for you should work ultimately. So here, this is just 1. It's going to be multiplied by x exponent 4. 3 exponent 0 is just 1, so it's going to be, I'm just going to jot it down for now, but it will be multiplied out. Next term we have is 4 x cubed, 3 exponent 1, plus 6 x squared, 3 cubed, or sorry, 3 squared is 9. Up next is going to be 4 again, x exponent 1 to the 27, 1 times 7 there. And the last one here is going to be 1 multiplied by, this is x exponent 0, which is just 1 ultimately, so let's write down our 1 right away. And this last term will be 81. There we go. Here, do all your multiplication together, so we have x exponent 4 plus 12 exponent 3, 12x exponent 3 that is, plus 54 x squared plus 108 x's, and last but not least, plus 81. There we go. This here is your full expansion of x plus 3 exponent 4. We have 2 more to do, and then we'll take a quick pause here. So this next one here, we have 3x squared minus 1 over x exponent 4, all cubed. Well, first things first, what I want to do is I want to rewrite this so that you don't have any fractions there. So that's what I'm going to do first. So I'm going to quickly do a rewrite here. This is the same thing as saying 3x squared minus x to the negative 4, all cubed. Okay. And right away, I'm just going to write down my terms. So if I have n equals 3, I'm going to go 3 choose 0. my x value was this entire 3x squared, and my first n value is 3 there, and my other y value is going to be, take that negative with it, negative x to the negative 4 exponent 0. So that's my first one. And right away, I'm cleaning up right away in these steps already. Like I'm not showing you too much work, and so I'm gonna add on 3, choose 1, 3x squared squared negative x negative 4 to the exponent 1. 3, choose 2. Sorry, I should have defaulted in my 1 exponent, 2 exponent right here. Last term, 3, choose 3. So you have 3x squared to the exponent of 0, negative x negative 4 to the exponent of 3. And there we go. And this is just the setup for my expansion. Now I'm going to go in, do all my cleanups, and then I'll multiply, and then I'll collect all my like terms. So 3, choose 0, that's just saying 1. Here, this one here is going to be 3 cubed, which is 27, and x to the exponent 6 because I multiply. This whole bracket here, because it's all exponent 0, will go away as 1. And we move on. That's a plus sign. Now we have 3, and we're multiplying that 3 to 3 squared, of course, is 9. I have x exponent 4 left over. And here I have my negative x negative 4. So that's exponent 1. Plus another 3. And this one is just 3x squared because that's to the exponent 1. And here, this one will be negative x times negative x, which is positive x. And negative 4 times another exponent, negative 4, really. So you basically you wrote this one out twice. Negative x, negative 4. And a reminder that when you're adding your exponents, because you are adding, because you're multiplying these two brackets together, you're adding up your exponents, it's still going to be negative. That negative sign does not disappear. Common mistake there, that a lot of people say, hey, it's squared, so then everything flips sign. Well, not really. Again, this is the same thing as saying this right here. So when you're squaring, that's what you're doing. You write out the same brackets twice, and when you're multiplying exponents, you're just adding them. Okay. So here, I'm gonna put that negative 8 exponent in red there, or sorry, in color, so that it brings it to your attention. Last term here we got is 1. Of course, this whole term here goes away as 1 as well, because it's all exponent 0. And here we get negative x to the negative 12. Okay. Going one more line, let's clean everything up. Let's do all our multiplication. So my first term is just 27 x exponent 6. And in this here, I'd have plus 27 because that's 9 and 3. X to the exponent 4. Ooh, and I should have a negative on that because it's negative x now. So let's erase that. Switch colors. Put a negative there. And here we have x exponent 4 times x exponent negative 4. Well, 4 plus negative 4 is 0, so you have 0 x's left over, so it's just negative 27. Could write x exponent 0 here, but again, that'll just clean up. And we're going to add on 3 and 3 make 9. X squared and x to the negative 8 makes x to the negative 6. And the last term here is going to be minus. Again, let's switch colors. Because positive, positive, negative, that's minus. Minus what? That's going to be negative x to the negative 12. From here, I'm going to clean up one more time just because I see x exponent zeros, I see negative exponents as well. I want to do a quick cleanup because I don't like exponent zeros and negative exponents, so I'm just going to rewrite it as 27 x exponent 6. That stays the same there, that's good. This is just going to be minus 27. This here, negative exponent flips down to your denominator, so this is plus 9 over x to the positive 6 now, and that looks a bit better because you like positive exponents. We're going to subtract off 1 over x exponent 12 positive now because we flipped that down to the denominator as well. We have another example here of another distribution, so let's get going. So right away, I'm going to have, if it's 4, I'm going to go 4 choose 0. My first term is 2x, that's going to be to the exponent 4. My next term is 2y to the negative 1, because I moved this y right up to the numerator, so it has a negative 1 exponent on it. That's going to be exponent 0 though. 4 choose 1, 2x cubed, and 2y negative 1 exponent 1, plus 4 choose 2, 2x, this time it was squared, and 2y to the negative 1, and this one's also squared. Our next term is 4 choose 3, 2x to the exponent 1, 2y negative 1 exponent 3. And I ran out of space, so I'm just going to write it right below here. So I'm going to add on a 4 choose 4, that's 2x exponent 0, and 2y negative 1 exponent 4. Alright, my next line, let's start to clean up all our numbers. So this is going to be 1. 2 exponent 4 is 16, so that's 16x4. This whole term here goes away as 1, so don't worry about it. We're going to add on to that 4. 2 cubed, of course, is just 8 now, so that's 8x cubed. And you have that 2y to the negative 1 there still. We're going to add on 4 choose 2 is 6, and this is just 4x squared. And here you'd have 4y to the negative 2. And then we're going to add on again 4, that's just now 2x multiplied by, that's 8y to the negative 3. And the last term here we're going to add on is just 1 again because it's 2x exponent 0, there's a 0 there. And this last one is 2 exponent 4, which is 16 y to the negative 4. There we go. From here, our cleanup step of multiplying, and I'm going to flip anything that has a negative exponent right away. So this first term is now just 16 x exponent 4 plus, and my numbers wise I have 4 times 8 times 2, which is 64. X cubed is going to remain in your numerator. That y exponent 1 or y exponent negative 1 flips to your denominator, becoming y1, y positive that is. We're going to add on 6 times 4 times 4, which is 96. X squared remains in your numerator, y squared in your denominator. 4 times 2 times 8 again, that's another 64. X in your numerator, y cubed in your denominator. And finally, you have your 16 numerator, because it's positive exponent of 1 on that 16, denominator, y exponent 4.